In the tank today, two engineers with a big idea to reduce pollution in recycling.
Hello investors, my name is Evan.
And my name is Luke, and this is our design, the EcoSort AI. Our project, the EcoSort AI, uses AI detection to accurately sort recycling from waste.
We're requesting 100% of this class for 3 months of labs and lectures.
What problem does your design address?
We believe there is a need for the way to reduce carbon emissions caused by excess waste on university campuses in British Columbia.
How does a robotic sorter address carbon emissions?
Landfills significantly contribute to climate change, responsible for 17% of Canada's methane emissions and 3% of its overall greenhouse gas emissions.
In 2022, it was estimated that the emissions from landfills were equivalent to those produced by over 24 million gasoline-powered vehicles driven for an entire year.
Both the UBC Vancouver and Kelowna campuses have acknowledged the need to address waste management through their on-campus management plans.
So how would you implement this design?
Achieving this goal will require institutional changes, such as continuing to improve around campus infrastructure and design.
So how much does your proposed design reduce the amount of incorrectly sorted waste?
By approximately 100%.
This solution helps to solve the issue mentioned in our needs statement, reduce excess waste. With this reduction, incorrect waste sorting and treatment of this waste decline heavily.
Therefore, CO2 emissions are majorly reduced.
To solve this problem, our group had to look at the source of the problem, resulting in a poor waste management. The extreme amount of waste being sent to the landfills is in the result of improper waste sorting.
When non-recyclable materials are mixed with recyclables, entire batches are contaminated and become unusable and unrecyclable, causing them to go to landfills, thus increasing pollution.
Oh, I see. So tackling the problem at the source reduced the most amount of carbon emissions.
Well, I gotta see how this thing works.
Me too.
We actually brought in a medium fidelity, works like prototype for you to see today. As you can see, there are 3 components: the entrance chute, the sorting area, and the funnels. The sorting area has a rotatable platform. See here for this demonstration, we have a piece of waste, it goes in the entrance chute, and the sorting system beams it down the correct funnel.
This is our scale prototype for the EcoSort AI. It uses a Raspberry Pi microcontroller connected to an SG18 servo with a 3D printed housing and lever slot attached to our camera, which relays live feedback to our AI detection software, which then processes it and successfully sorts recycling from waste. Here's a live demonstration of how our product works. Let's start by testing a piece of recycling, like this bottle cap, this starburst wrapper, another piece of garbage, and finally this piece of cardboard.
So we need to know the monetary side. Let's look at the cost-benefit analysis of your solution.
Absolutely. Because this system involves robotic units, its initial setup cost is around $200,000. 5 years after installation, it saves $250,000 in labor costs alone.
And that's not all. The robotics recycle efficiency by 20%, which diverts 500 additional tons of material from landfills. That saves $25,000 in landfill and reduces 65 metric tons in CO2 emissions.
Worth $28,000 in environmental savings.
The system also retains a salvage value of 20 grand after 5 years. We can calculate the total benefits and costs by the net benefit of $28,250 over the same time frame.
Beyond monetary benefits, does the system promote sustainability?
Yes, while lowering emissions, it engages students in eco-friendly practices, overall creating a greener, cleaner campus.
Well, I can see your prototype only has 2 chutes. How do you plan to expand this to include compost and returnables in your design?
Good observation. As you can see, as you know, this was made on a $100 budget. So with the larger scope of this project, we considered adding a tilt forward, a tilt back, a different mechanical system, which could lead to more chutes and a more variable recycling system.
You know, I like the idea. I think my best offer is about 65%.
I really like your design personally. I think that this is a great pitch and could really help the community. So personally, I'll give it a 93.
I'm not gonna match that. I'm not.
I do think it's a really strong